Hello everyone and welcome to the webinar. This is Sydney speaking, and as you all know, today's webinar is going to be based on what we call feature recognition. Now, the types of feature recognition that we actually have in the program is we call pocket recognition, and we also have what they call drill recognition, and we also have something which is very, very new, also chamfer recognition. But what I'm going to do in this webinar is more than just show you the options, which I've done in the past, but I'm actually going to take the apart and compare it to the way we used to have to program the part, whether it be individual pockets. And we're going to go through all the operations as in the regular 2.5D process, and then see how the feature recognitions actually save us a lot of time in programming and just gives us a lot less of a headache as far as working on 2.5D parts. So let's get started. Just a quick reminder though, if you do have questions, you can always ask questions just by simply clicking on raise hand. In the area where it says questions, just write down your question. And of course, at the end, when you finish writing down your question, don't forget to click on the send button so that we can actually see the questions at the very end. And then I can go through them and try to answer them to the best of my abilities. Okay, so let's get started with the webinar. And you can all see the part that I have on our screen. And let me just go through the part itself, what I have over here. What I have here is several different areas which I can consider them as pockets, and I have all different types of drills over here as well, different holes that I need to recognize. I have pockets, for example, this floor over here, I can consider that as a pocket, as an open pocket in this particular case, whereas this area inside over here is a closed pocket, same as this area over here. And then I have this pocket over here, which is on a different level than this pocket over here, together with this pocket, which also open on one side. This surface itself, I can also consider that as a pocket with all the sides open except for one side over there. This area over here can also be considered a pocket, as well as this floor over here, and these narrow slots over here as well. So there are different types of different operations I have to do in order to complete them, and I can do this actually very well with your regular 2.5D operations. But the idea behind the thing that always bothered me in the past about that is that it would take a long time to program it, because I'd have to recognize every single individual depth of pocket and different types of geometries, and always defining every single geometry on every single level in itself. So let's actually get started. And what I'm going to do is I'm going to go through the operations I already have here on the side. And these operations are actual operations that I had to do in order to create this part using the regular 2.5D operations. And you'll see the pain that I'm actually going through in order to go through it. Okay, our very first operation, I'm just going to quickly pass by. That's just a face mill operation, so that we're going to keep the way it is. And our second operation was just doing the outside of the part itself. Now, let's start from this operation in here. In this particular operation, what I'd like to do actually, I first want to start off actually clearing off these areas over here. So I've done that using a pocket operation, and I'll go into the operation itself. And in order to do this, what I had to do was create my geometry. And in this particular case, to create the geometry, I created a chain on this area and on this area as well. And then after I created the chain, actually let me go into edit, I would have to go into each one of those chains and also mark the open edges of those particular chains, to mark them as open, and do the same thing for the next one over. After doing all of that, I would accept it, and then of course, I would have to choose my tool. And after choosing my tool, I'd have to go to levels. And when it did levels, I would have to make sure I picked the proper upper level. For my part, in this particular case, it was over here. And then, of course, I would have to choose my pocket depth as shown over there. And then, being that this pocket is an open pocket, I have the technology of open pockets available to you. Use any kind of strategy I want over there. And if I would run my simulation, you'd actually see, and let me just do this a little slow over here. You'll see that the tool actually goes down and works on every single one on that particular pocket, clearing it off, no problem. It actually does it very, very nicely, but you saw what I had to do in order to get that to work correctly. Okay, but now I'd like to do the same thing, but this time I'd like to work in this area over here. Well, for that, since it's on a different level, I have to do that in a different operation. So again, I had to start a new operation over here. I had to create my geometry, again choosing my geometry around those chains over there, and again in each one of those chains I would have to go in and mark open edges and do this again on these edges over there as well. Again, I have to go back, choose my tool, and of course we have to choose our proper levels. If I take my pocket depth, you see I had to go down to that floor over there. And then if I ran my simulation over here, and I'll just put this in isometric view, you'll see that the tool actually does exactly what it's supposed to do to clear off those areas itself. And it does it very well, no problem. But again, note I had to do I had to choose my geometry, choose my open chains, everything that I had to do over there. But that's not all. If I went to my next operation, I wanted to clear out these areas over here. So again, since it's a different depth, I had to go again, open up, create a new geometry, and again, mark my open edges. In this particular case, the open edges was this edge over there and this edge over there. Again, I would have to choose my tool. Again, I would have to choose my levels, the proper levels, and of course, the proper technology with the open pocket, whichever way I want to work. Running the simulation on that, you'd see that in that case, it would do those pockets there as well. And again, it does it well. I'm not saying it doesn't do it well. It does it very well. These are very easy operations to do. But note, I have to do this for every single one of those pockets. But wait, I'm not even finished. We still have another pocket to deal with. We have to deal with this pocket over here. Well, in this particular case, I go into my operation, and again I have to create my geometry. And let me actually create a new geometry just to show you what I had to go through. Now, since this particular geometry, I just want to go from here up until here over here. So up until this floor over here. So I need the top edge over here only, and then a line going across over there. Now, if I picked automatic Z at the bottom, it would actually go back and forth inside these slots, which I don't want. I actually do not want to have that as part of my geometry right now. I just want to have it go across over there. So I'm just going to show this to you because some people don't know about this particular option in creating a chain. I'll start by choosing my chain over here, and then I'll choose Auto to Constant Z up until this edge over here. Now, as I said, since it's a pocket operation, I have to close it. But instead of choosing point to close it, all I'm going to do is accept it at this point. I'm accepting actually an open chain. Now, when I do this, on this particular case, it tells me it's open. Do I want to close the chain with a line? I can say yes, but not only do I can say yes, I can tell it also mark that line as an open edge, which it is in this particular case. So I'll just click on yes, and then I have my geometry over there. Okay, now I've already created it, so I'm not going to save what I did over there. But again, then I have to go back and choose my tool, go back and choose my levels as shown over here, do all the options that I did before over here, the open pocket, save and calculate, simulate, and then again, run my simulation, and you see it clearing everything out exactly the way it was supposed to. Not a problem over there at all. Well, you know what? I still have these slots over here to do. Now you see all these operations I'm starting to create just to do the pocket operations. Well, you know what? In this particular case, I have these slots over here. So I decided to be a little fancy over here. I decided to use my toolbox operation, because in the toolbox I already have something for these type of wide slots, which I chose over here. And I have my geometries, these two particular slots, as shown over here. I chose the proper tool that I needed, and of course I have to choose my levels. Just running my simulation, you'll see that it actually does those two slots. But still, I am not finished yet. Okay? I still have to do this pocket over here. Now, this pocket over here are these through pockets as shown over here. Well, what I'm going to do over here, again, you have to have my geometry. In this particular case, all my geometries I have here, these 4 closed chains, they're just closed chains. I don't have to mark anything as open chains. So that was a little bit easier. But still, I have to choose my tool. I have to choose my upper level, make sure I choose the proper upper level. And, of course, I have to choose my pocket depth. And in this particular case, since it's a through pocket, I told it delta -1. Running my simulation again in this part. Let me actually put it on the side over here. You'll see that it actually mills out those pockets over there. We'll speed it up a little as it mills out every single one of those pockets as shown over here. Milling out this one, then going down to that one, to the next one over there, until it finishes this one over here. And all those pockets are now finished. But you know what? Sorry guys, I'm still not finished yet. I still have to do these pockets over here. So again, I have to go into make another operation, create another operation. Again, I have my geometries, these closed pockets over here, and my levels. Again, note, for every single one of them, I had to create different geometries and different levels every single time. Running my simulation, let's just do it now without the solid verification. You'll see that the tool actually goes, let me show the actual tool path. The tool goes and works on on those 2 pockets exactly where I need to work on them. But wait, we're still not finished. What about these slots over here? Well, again, I decided to use the power that we have outside of pocket operation over here for this particular case. And I used what we call also something in toolbox. And I just created a geometry on this one slot over here. I was lucky enough to have this part where every single one of these was exactly equally spaced and the exact same on the part itself. So all I had to do was create one geometry, choose the proper tool I needed, choose my levels as shown over here, and then I went into transformation, and in transformation I just chose the number of copies. I had 10 altogether as shown over here, and the space between those as well. Okay, just accept everything I have over there, run my simulation. Let's actually do it using actually solid verify this time, and we'll put this on the side over here. Just a moment, please. Okay, here we go. We have this over here. Run my simulation, and you'll see it'll do every single one of those slots. Let's actually do it using HostCAD and show verification as shown over here. You can see that over here as well as it runs the simulation on every single one of those slots over there. No problem at all. Well, let's see what I did over here right now so far for all of those operations. I did starting from this point, I had 1, 2, 3, 4, 5, 6, 7, 8 different operations I created for this particular part, just to take care of the pockets. Now, remember, each one of those, I also had to create geometries, For each one of those, I had to mark wherever they had open edges. For each one of those, I also had to mark the proper depth as well. So let me actually right now suppress this, what I've done over here. And now let me do the exact same thing, but this time I'm going to use the option of pocket recognition. We'll go into this let's first take all of these over here, as I mentioned. And I'm going to suppress them as if I never did anything. And after this operation over here, I'm going to add my pocket recognition as shown over here. I'll create my geometry simply by just touching the part, but I just want to make sure that these small pockets, small diameter pockets, are not chosen. Okay, so anything that's smaller than, say, 20 millimeters, I don't want to choose that as a pocket. Now just click on the part itself. It's recognizing every single pocket that's over there, every single surface, every single depth. And as you can see, every single one of them was chosen. And you can see that over here as well. I'll just accept that. And you know what? Let me just go into modify, because the very top surface I don't need, because I've already done that with a face mill. So I can say just exclude my top faces. Okay, I'm just going to choose my tool. The proper tool that I need over here. And note when I go into levels, I do not have any depth to take care of. Everything is taken care of automatically. It's recognized off of the geometries itself. The only thing I'm going to really do here is maybe click this where it says adaptive step down. So any kind of a step that may occur in between this particular step down over here will be included as well. In my technology, I do have the open pocket strategy. Let's just choose the option of approach from outside. In my link, I have my helical approach. If I want, I can choose make a smaller radius over here. Let's say I have it a 3 millimeter radius for all of them as it goes in, and we'll just accept that exactly the way it is. Okay, running my simulation, you'll see the following. In one operation, okay, in one operation, we are actually doing every single one of those surfaces over there. Every single one of those pockets are being done in one operation. What I did here before in all of these over here, I did this now using only one operation. I didn't have to choose different geometries. I didn't have to mark anything. That was an open pocket. All of this was done in one operation. And note, these slots over here were not done. Why? Because the tool cannot fit in there. No problem at all. All I'm going to do now is save and copy. And using the same geometry I had before, I'm just going to change my tool to the smaller end mill that will fit inside that area itself. And in my technology, I'm just going to use the option of rest material chamfer of rest and put it in the previous diameter, which was a 16 millimeter end mill. Let's run my simulation in this particular case. And what's actually going to happen now, let's just finish its updating its stock. Which gives me a good chance to drink a quick glass of water. You note that it worked on just these areas over there. Let's actually do this using Solid Verify. You can see that a little better. Note, you have these slots over there. It's working only in those slots, the only place where it has to work. And I didn't have to choose any kind of other geometry at all. It automatically recognized it off that exact same geometry I had before. Okay, so what I did here was very simple. I did two operations, one for the bulk of the pockets and one for the rest material, which was in this area over here. Two operations instead, and I did not have to choose any kind of depth over here. And this was done in two operations instead of 8 operations where I did over here. And remember, every single one of these operations that I did over here, I had to choose a geometry, I had to choose a depth, I had to mark each geometry that were open as open edges. So there was a lot of work involved doing each one of those. Whereas in this particular case, it was done quickly without any kind of pain, just being able to get the exact same type of results. Okay, so now let's continue now to our next step. And I'd like to actually start doing some drilling operations. Well, if we take a look at the part itself, we have all different types of diameter holes on top over here. We have also this particular hole over here, this series of holes, which is a 6.8 millimeter hole, the same as this hole over here, which is also 6.8 millimeter hole, but on a different level. We have different holes on different levels over here as well. And I'd like to start by doing a spot drill using our regular drilling operation. Well, what I did was very simple. I had to go in here, choose my geometry. In this particular case, when I chose my geometry, I had to actually filter out the holes because I only wanted them to pick these holes right now because I want my spot drill to go up until this diameter. And I can't have that happening for these holes over here. So I have to do that with different in a different operation. So this time I filtered out these holes over there, just chose those holes. I had my chamfer, my spot drill over here, my levels, going down to my 0 level up until a specific diameter, which was chosen over there. And then if I run my simulation, running my solid verify simulation, you'll see it went down exactly the way I wanted it to. But note, in one operation with the spot drill, I was only able to do those holes over there. Now, in my next operation, I actually wanted to continue doing a spot drill, but this time on these holes over here. Now this particular one is larger than this one over here, so I couldn't do that in the same operation and get to the proper depth that I needed to do over there. So again, I had to create another operation over here. This time my geometry, I chose those 4 holes only. And again, I had to choose my tool, same tool, levels, the same thing over here, but this time I have a different diameter value that the tool will have to go down to over here. Running my simulation over here again, using Solid Verify, this time you'll see it goes down to those areas as shown over here. Same, but it cannot be done in the same operation as this one, as this depth over here is deeper than this over here. Okay, well, next what I wanted to do was I went back and then did a regular drilling operation for this. And when I did the drilling operation, of course, I chose the proper geometry which I used before. I chose the tool that I had to use before, the levels. And remember, over here I had to choose the levels. Of course, I did my pecking, whichever I need to do. Running my simulation over here, you'll see that the tool, let's actually do this using Solid Verify. You see the tool going down in each one of those holes, drilling out every single one of those holes. Okay, that's no problem at all. We'll do that for the next operation as well. This one is a larger hole over here, so we're going to use a different drill, which is perfectly okay. Again, making sure I switch geometries over there. No problem, I did that as well. Okay, now next, I wanted to drill at work on these holes over here. Well, for that, again, I did a spot drill. And note, this is the same diameter hole, but I can't do the same operation for this one as well as this one because they're on different depths. So I created one over here that included these holes over here only, this set of holes over here. I used my spot drill over here and my levels according to what I needed over here, going down an extra 0.2 millimeters as to create a little bit of a chamfer on these edges over there as well. Having this as my diameter value picked off the part itself, I was able to do that. But note my upper level in this particular case is 0. Running my simulation, you'll see it'll do it very well. But again, I had to do it individually. Now, Going to my next operation, again I did a spot drill, but this time I needed it for these holes. So again I had to do that as a separate operation. Again, choosing different geometry for that. I used the same spot drill, however, and my levels this time, my upper level was -10, taken directly off the part over there. Because it was not 0, it's a different level. This is why it's a different operation. But the values over here were the exact same thing. And then I continued on down doing spot drills for these holes, like I said over there, as I showed you over there. And then I went down, continued on with some of these holes down over there, drilling out over there. And you know, every single one of them I had to do separate spot drill operations. Well, you know what? Let me do something else as far as spot drills goes. Now, if I were to do a spot drill operation, I would like to do a spot drill operation in one operation where the depth of the spot drill goes down to the proper depth for each one of these holes individually. Well, let's do this. I'm going to go over here. Okay, and after this operation, I'm going to add what we call a drill recognition operation. And what I'm going to do is create a new geometry. And so as not to include these very large holes over there, what I'm going to do, I'm going to actually limit the hole diameter to work from one area up until a specific hole. Let's just take from which hole. I'll just mark this area over here and lighten that area over there and just click on that hole itself. You note it picked 6.8. Now up until what diameter? If I leave it over here, it'll only do 6.8. But I can go over here and say I want it to go up until that diameter over there. And now click on Find Holes. Now, checking each one of those areas, you see every single hole was chosen over there. Different levels, but every single one of them was chosen. I'm going to choose my spot drill that I need over here. And then let me go to my levels. Now, in my levels, I'm just going to do one thing. Since I want every single one of them just to go down to a specific depth, individually according to the diameter of that particular hole, and maybe even creating a little bit of a chamfer over there, all I have to do is go into Depth Edit and do the following. Going all the way down to the bottom, we have Auto Chamfer Spot Drill, which is exactly what I want in this particular case. I'll click on Auto Chamfer Spot Drill, and I want it to do work on all of the groups that I have over here. So I'll click on All and Apply. Now this is being done to every single one of those groups holes over there. Now, as far as my chamfer depth, I want my chamfer depth to be at, say, 0.2 millimeters, and I want that for all of my operations here as well, clicking on Apply. And that's all I have to do. Now what's going to happen is very simple. When I run my simulation and Solid Verify, what you'll see is that each hole that has a spot drill on it, which is being done right now, every single one of them is drilled out with the spot drill until the proper depth that I need to know. You'll note that this one is different than this one over here. You have this one over here is different. All of them to their proper diameter over here. So in one operation, I was able to work on excuse me. I was able to work on spot drill, doing them all in one operation. Just to note one thing, that these holes, as you see them now, okay, they all are flat to this surface over here. If the hole was coming in at an angle to a wall, or if the floor was at an angle and the wall and the hole straight down, we're giving the top as an oblique area. It may have a little problem picking that up. Okay. There are certain limitations in that, but we are working on that as well. Okay. Now, let's continue now. And let me just do these holes over here. I'm just going to pick that out once. And note, these holes are the same diameter, but at different depths. So I'm going to create another drill recognition operation. This time, I'm only going to have it work on that particular diameter, as I'm working only with one. This is a one tool operation. Hole diameter. What's the diameter I want? I'll just click it there immediately off the part itself, 6.8. I'm going to leave that. Note when I do find holes, it picks out those two groups automatically. I'll just accept that. I'll choose my tool, and I'll choose my 6.8 drill. And in my levels, I'm not going to do anything. I'm just going to leave it the way it is. I'm not going to pick out what depth it has to go to and from where it has to start. It's automatically recognized in the operation itself when I picked out the geometry. All I have to do is maybe in technology, if I want to choose my pecking, tell it what my step down is. Let's just give it a step down of every 3 millimeters, and that's it. Save and calculate, simulate, and again, running Solid Verify, you'll note that every single one of those holes were drilled out to their proper depth. And if I zoom in on them, you can see even a little bit of a chamfer was left over on them, which was created for the spot drill. And those were created automatically on the proper depth. So it left that chamfer over there exactly the way I wanted it to be done. Now, this was done very simply by doing the drill recognition operation. But now let me actually go on to my next set of operations. What I'd like to do now is on all the edges around over here, including these edges over here, this edge over here, this one down here, this in here, even these edges over here, I'd like to actually break the edges, do a little bit of a chamfer operation. Well, the way I would have to do it, I had to do it beforehand, before we had the new chamfer operation, was very simple. The top edge over here was not a problem at all. It was all open, and if I were to go into the operation itself, you see I just have to choose my geometry, which was all of these edges over there, as well as this slot over there. Note I have to pick all the edges over there by myself. Choose my chamfer mill and my levels, put in the proper upper level and the profile depth, and then of course tell it that I'm doing a chamfer operation and what diameter of the tool I'm using. If I were to run my simulation on that, running Solid Verify, in just a moment, because doing all of these operations here as well, you'll note that those edges, as I zoom in, were done properly with no problem. But as I said, I want to do the other edges as well. For example, I'd like to do these edges around here and this edge over here. Well, this is not really that much of a problem, these closed areas over here. But these areas over here, I can do them, but I also have to make sure that when my tool goes down, it doesn't get to these corners over here. In other words, I have to actually do a modify on my geometry, making sure my tool doesn't go in there at all. So again, I'll choose my new operation. Again, I have to choose my geometry, as shown over here. These chains over there, the ones on the other side as well. The tool, same exact chamfer mill. My levels, my upper level this time being the surface over there. And if I go into my technology, of course I use the chamfer option and the chamfer cutting diameter, but if I go into my technology, I had to go into modify geometry. And when I did modify geometry, changing to the top view, you'll see that I had to make sure that when it gets to these edges over there, it actually has a negative extension so that it works away from that corner. The same thing over here in this edge. I have to make sure that the tool does not get to the corner itself so that it doesn't gouge into the corner itself. So I had to put in this value over here to make sure it doesn't get to those edges over there. Of course, it worked out very well, no problem at all. Running my simulation again using Solid Verify, it was able to do every single one of those edges exactly the way I wanted it to be done, as shown over here. Well, but that's not enough. I had to do the same thing for these edges over here. Let me zoom out a little. For these edges as shown over here. Again, I had to choose that geometry. And again, in this particular case, let me just go into my technology. I had to do a modified geometry to make sure that the tool does not go up into that corner. So I made an extension, again, -5 on both ends over there. And again, I was able to do that, but I had to do that in a separate operation. Now, but the pain hasn't ended yet. I had to do this up and for these operations over here. If I were to open up this operation over here, my geometry in this particular case was these edges around over here. I had to make sure in this particular case that, again, I have my proper levels, and in my technology that we have, again, the extension was done correctly. Finishing that operation, running my simulation on Solid Verify over here, you'll see that it did it, doing it correctly also again over here. But again, I had to do an individual checking, creating a geometry, and also making sure that it doesn't get to those edges over there as well. And I still also had to do that, not only over there, but I also had to do that at the very bottom over here. This area over here, where I had this closed pocket, but I also had this area, this edge over here as well. And this edge, my extension, I had to be even a little bit more cautious, because if I take a look at this edge where it comes with an arc over here, if I told it to go back 5, it may still hit this wall, so I had to go back even further. If I were to open up the operation, you'll see I had to choose, of course, again, my geometry. And if I go into my technology, this time, going to these edges over here, I did a -10 because I had to make sure that this edge wouldn't get towards that corner, that wall over there. Well, let's see how I can do this now using a simple operation, what we have right now, which we've added very, very recently, but it's a very, very powerful operation. And that's the Chamfer Opera recognition. I'm going to go to this point over here, so it comes in before these operations, so we can see that clearly without any problem. I'm going to do what we call adding an operation of chamfer recognition. And choosing a geometry over here is very simple. It's almost as simple as choosing a geometry for drill recognition. I'll choose my geometry just simply by creating a new one. Now, there are holes over here that I don't want to create a chamfer on, so anything less than, say, 25 millimeters, don't take that. Okay, now just choose my part itself. It'll recognize every single edge that's on the part itself. No problem at all. I'll go to my tool, choose the proper tool that I needed, which was my chamfering tool. And note when I go to my levels, the only thing I have to put in here is the actual depth of the chamfer that I want on those edges itself. Now, in my technology, this is where it's really brilliant. We have a cutting diameter, which is the diameter I want to use, but we also have something called safety offset. This safety offset is exactly what is needed to keep it away from all of those corners over there. And this is automatically calculated. I have complete control over here, but this value that you find in here is automatically calculated according to the cutting diameter that I use. If I've changed it to, say, cutting diameter of 2, you'll see that the safety distance changes over there. Put it back at 1, you see it changes there as well. It also has to do with the levels of my chamfer depth as well. Now, note I'm putting in here the value over here is 3.5, and it automatically takes into consideration these edges over here where I have the arcs actually going towards the wall itself. It knows how to recognize also the proper distance from that as well. Of course, we have our links if I want to say have it go in normal into the part itself. And now let's run our simulation. Now note all of this is being done in one operation on the part itself. Let me slow it down a bit. The tool is actually going down, creating a chamfer on every single one of those edges that are over there. And note, it kept it away from the wall exactly the way it should be over there. Same thing over there, making sure the same thing is done over there as well. And it did every single one of these edges over here without getting into that corner over there as well. Note, this was done in one simple operation. I did not have to pick any kind of edge over there, any kind of geometry. This was done all in one operation and all at the proper depth as well. So, as we can see, using the feature recognitions instead of using all of the other operations, it many times saves us a lot of programming time. I can do it the other way as well, as I've done it, but as far as the time spent doing it, this is a lot quicker. In the chamfer recognition that I did over here, note I did this one operation instead of doing 1, 2, 3, 4, 5 operations. This took, in this particular case, 5 operations, and if I had different steps over here with different depths, it would still do this all in one operation instead of the amount of operations I would need in order to have to do that as well. Okay, now before I finish, I'd like to go back to pocket recognition, because there's one thing I didn't show you yet in pocket recognition, which I'll show you actually on a different part. Well, what happens in a pocket where I have a fillet at the very bottom corner of the pocket itself? Now, I'm going to load a different part. Okay. And you'll note on this particular part over here, we have different pockets over here. We have one over here as well. And this has the regular sharp corner, but note these pockets over here. This one has a radius at the very bottom over here of 1 millimeter. This pocket over here, which is a different depth, has a radius of 3 millimeters. This one over here has a radius of 2 millimeters. So we have different pockets, different radiuses, and well, the way I would normally do this in a regular pocket operation is I would have to go over here and create different operations for the different levels. Say, for example, I wanted to do these pockets over here. Well, the way I would do that is very simple. I go in here, create my geometry, being these open pockets as shown over here. And note, I pick the edges going up all the way up into the wall, not the ones at the bottom. I have my tool, I have my levels, and in this particular case, the level, I'm only going down up until that point over there. And of course, since it's an open pocket, I have my open pocket technology. And if I run my simulation on the part itself, you'll see that it works up until that point over there. Let's just get rid of the tool pass itself. You can see exactly where it's working to. Well, I had to continue down to the next level as well. But this time, the next level, I had to work to make sure that I don't gouge into the radius over there itself. So in my next operation, I actually use the exact same geometry, the exact same tools, but this time my levels started from this point over there, going down to the pocket depth over there. And what I did to make sure that it didn't go all the way up into the wall was go into my technology, and I did a wall offset of 3 millimeters. And if I run my simulation again, this time it does this area over here, but it leaves that step. This is fine, but you know what? In many cases, I like to have a few steps over here, so I would have to actually start calculating in my head and working out on paper exactly how deep to go every single time, and how much of an offset to do on each one of those levels. But that's not the only thing. I had to do it as well on these pockets here as well, doing it for this pocket over here with its geometry going down up until that area over there, and the same thing with continuing on down up until the floor over there, and the same thing with the last two over there. Let me just run the simulation on all of them in one shot. And you'll see, I'll speed this up a little. Every single pocket was milled out in a regular pocket operation, but with this step over here, which is the way I wanted to do it. Now, again, really what I would really like to do is have several small steps over there. Well, you know, let me make it a lot easier now. I'm going to take all of these operations that I did in a regular pocket operation. I'll suppress them. And what I'm going to do is go into my pocket recognition operation. And my pocket recognition operation, I'll do the exact same thing I did last time. I'll just click on the part itself to pick out all the pockets. And note, I'll go into modify also to exclude the top surface over there as well. Now, if I go into tools, I'll choose a proper tool that I need over here, as shown over here. And in my levels, just like before, I don't need to choose any level. I'll just add the option of adaptive step down. Technology, if I have open pockets, I'm just going to I'll just use the options that I have here in open pockets. Save and calculate. And let's run our simulation. Running our simulation, you'll see it'll do every single pocket automatically. And it automatically also recognizes the diameters that I have over there without me having to do separate operations for each one of them. It recognizes that automatically in each one. But you know what? Remember, I did say that I want to have these large radiuses over here with more step downs, with more steps on it instead of the typical one step as I did over there. Well, let's go back into our geometry and go back to modify. In modify, we have another option over here called divide floor fillets by steps, which it did. Now we have an option over here of going into the number of steps. Well, note I had different size fillets over here, and it automatically recognizes that the maximum fillet was 3 millimeters as shown over there. So that's picked up automatically. So it's telling me like this: anything that's between 0 and 3 millimeters, do that in one step. And that's the default value. And that's exactly what it did. But I can actually open up the next line over here. Now look what happens to this 3 over here if I open up the next line. The 3 actually jumps down to here and divides this in half and says, okay, everything between 0 and 1.5, I want you to do in one step. Everything between 1.5 and 3, do that in 2 steps. But you know what? I want to go even further. So again, it'll go down, making sure my maximum fillet radius is over here as well. Now, if I change any of these values, say I change this from 1.5 to 1.25, in my next line over here, it'll automatically start from this point over here. And of course, if I want, I can change these values in here if I want. I can have this say anything from 0 to 1.25, do it in 2 steps. Just have it in 3 steps, and anything that's past 2.25 up until 3, do that in, say, 5 steps. Click on OK, accept that. And if I run my simulation, note what happens to the steps over here. You'll see that in this particular area, we have 1, 2, 3, 4, 5 steps actually on the part itself, on the 3 millimeter radius. In this area we had a 2 millimeter radius, we have 1, 2, 3 steps. And where I had the 1 millimeter radius over here, you'll see that I have 1, 2 steps. So it was done automatically without me having to do all of these different operations just to get down this area. And if I really wanted to end up looking like this, I would have had to done that operation in several operations to get down to exactly the way I wanted. Okay, so basically what I showed you in this webinar was how quickly you can use your feature recognition operations, such as the drill, pocket, and even our newest one of chamfer recognition, how to be able to create the different geometries in a much quicker than we did before, with a lot less pain of picking all the different geometries. Okay, let me just go through the I have two questions over here. I think one of them I answered before was what happens if that the holes are perpendicular to the top face. What happens if the top face is on an angle, such as a 60-degree taper, for example, and if the top will pick up the top hole over there as well. In that particular case, no. However, where it breaks through at the very bottom, if that hole breaks through if there's a regular hole that's flat on top, but it breaks through a surface at the bottom, it'll go to its most deepest area in that particular hole. Okay, now this webinar has been recorded, and it will be available on our website together with the part itself. I hope you enjoyed the webinar today. Take care, everyone. Have a great weekend, and see you in our next webinar.